Mechanism of nucleophilic addition reaction. A nucleophile attacks the electrophilic carbon atom of the polar carbonyl group from the direction approximately perpendicular to the plane of the sp2 hybridized carbon of carbonyl carbon. The hybridization of carbon changes from sp2 to sp3 in this process, and a tetrahedral alkoxide intermediate is formed. Here the hybridization of carbon is sp2 and it is changed to sp3. It is planar and it is tetrahedral, and it is the tetrahedral intermediate. It is a tetrahedral alkoxide intermediate, even we can say. This intermediate captures a proton from the reaction medium to give electrically neutral product. The net result is the addition of nucleophile and the proton across the carbon oxygen double bond. So nucleophile is added here and the proton is attached to the oxygen. So this way the nucleophilic addition reaction takes place in aldehyde and ketones. Now we will be discussing about the reactivity, that aldehydes are generally more reactive than ketone in nucleophilic addition reaction. So the question is that why the aldehydes are more reactive than ketone in nucleophilic addition reaction. First reason is steric hindrance. The increase in the size of alkyl or aryl group around the carbon atom will pose steric hindrance to the attacking nucleophile. Naturally, if the large group is attached here to the carbon, the nucleophile will not be able to attack the carbon. And second is the alkyl group show plus I effect and thus increase the electron density on the carbonyl carbon. As a result, the attacking tendency of the nucleophile decreases and lesser is the reactivity of the compound. Larger the alkyl group, larger is the plus I effect and lesser will be the reactivity of that particular aldehyde or ketone towards the nucleophilic addition reaction. Now in general, the aromatic aldehyde and ketones are less reactive than corresponding aliphatic analogues. Why? It is due to the greater delocalization of positive charge on electrophilic carbon due to the resonance. The polarity of the carbonyl carbon is reduced and hence it becomes a less reactive. So I have shown it by drawing the resonating structures. You can see here this pi electron will move towards the oxygen because the oxygen is more electronegative than carbon. Carbon will get the positive charge and it is a site for the nucleophile to attack, but due to the resonance there is a charge dispersion, there is a delocalization of positive charge on the electrophilic carbon due to the resonance, and thus the polarity of the carbon is reduced. So we can say that the aldehydes are generally more reactive than ketone in the nucleophilic addition reaction due to the steric and due to the electronic reason. Now you will be reading the physical properties of aldehyde and ketones and you will be answering these questions. I would like to repeat these questions, that why the boiling point of aldehyde and ketones are higher than the hydrocarbons and ethers of comparable molecular masses. Second is why the boiling point of alcohol is more than aldehyde and ketone of same molecular masses. Then I have given one question that you have to arrange these compounds in the order of their increasing boiling point. Lower member of aldehyde and ketones are miscible with water in all the proportions, but the solubility decreases on increasing the length of the alkyl group. Give reason. You have to write these answers, but read the topic physical properties of aldehyde and ketones first and then answer these questions. Thank you.